So we finished our rainfall on our project, and now we're going to start with the 3 different forms of infiltration. If you're working through these, don't complete all of these. Just pick one of them, the one that you might think you might use, and perform only one of them. They're all about the same length. So let's start with the curve number 1. So we're going to start with how to get curve number data from the curve number generator. So the curve number generator is going to go online to the, I think it's the NLCD and the SSURGO. I call that Sergio if you don't like that, sorry. Websites and like download their data, and then it's going to intersect their data and generate a curve number layer. So I'm going to just set most of these to temporary just so that you can see them. But you don't have to download them at all, or you don't have to do that at all. You can just leave those to skip output, and it'll skip the output if you want. And then for this one, I will typically save this one to file because this is the one that we're looking for. And as you can see, I've already done this, so I'll just go ahead and replace that one. And then I'm going to click Run. So now it's going online, downloading the data from the different servers, and then it's going to intersect the data and then sample it from the raster, and then it's going to build this final curve number layer. So the process is complete, and we can now close the curve number generator. And again, if you want to get to curve number generator, you go to the toolbox and you just double click it right here. I'm finished with the toolbox at this time, so I can either go back to Flow 2D or I can close it. I'll just leave it alone for now. Let's leave it open. Now these are the layers that it gave us. So first of all, let me minimize these layers just so we can look at them individually. So first layer was the Sergio soils data, and this is a scratch layer, meaning that it will be removed from your project when you close the software. This is your standard tip. Sorry, that is annoying. That tooltip is annoying. This is your standard soil polygons downloaded from that soil polygon site. This is from the land cover. This will be impervious surface. So this would be like the kind of like the percent impervious. Let's see what percent impervious. That's from 0 to 100. And this is the land cover categories. So it will be, oh, let me turn off this one real quick. And so you can see that most of this is developed, medium, low, or low intensity, and a couple of open lighter colored areas. If you wanted to see what an individual area was, an individual pixel, you could use this tool and you could just click on an individual pixel. And this data, I believe when you get this data from the NLCD website, I believe it is in lat long. So that's probably why our polygon is kind of skewed like this. And you can see the band would be this pixel right here, this lighter colored pixel right here would be 21. And if we came over here, that would be developed open space. If you turn your comp domain off, it might be a little easier to see. And this is about a 30-meter cell size. So this land use data is not the best resolution, but it works pretty good for like I would say it works really good for solar projects, maybe overland projects, tailings dam projects, dam breach projects, things like that that are maybe not in as crowded of areas. And what that data did was it created this layer right here called the curve number layer. So I'm going to right click, open attribute table, and you see here that you get the soil group, the land cover number, and the soil code, or the grid code, and then a calculated curve number that is this is done using an algorithm that uses these codes and a lookup table to get you a curve number for this data. If we sort this high to low, you'll see your high and low curve numbers right here. Curve number data for Flow 2D should not go above 99, and I don't really know. This is a pretty low curve number for this project. I would say maybe don't go below 63, but that's up to you. You probably know more about that than I do. I'm going to click Edit, set this to curve number, just to show you how easy it is to sort this kind of, or to, excuse me, manipulate and edit this kind of data. I'm going to select any cell, or excuse me, all of the polygons that are 52, and let me turn off these other layers real quick so that you, and let me turn off the grid real quick so that you can see that these are the areas I selected that are 52, and I will, sorry, wrong file, wrong table. I will set the curve number for these. So I set this to curve number, and let's just say that we want to drop ours out. Anything less than 63, let's increase it to 63, and I can click update all. No, sorry, update selected. And you can see that that's a really quick way to modify a low range of data. I'm going to save this, and then I will turn the editor off and close the attribute table. If we come back to Flow2D, we can now use this data to generate a curve number for our grid. So, infiltration editor, and we open the global infiltration, and we want to use the curve number. So I set this to global. This, don't worry about this number, it's going to be replaced by the local curve number value. And this initial abstraction will only be used if it's higher than the initial abstraction that comes from the curve number system. So the curve number automatically has an initial abstraction related to the curve number. So I'm done with the global, click OK, then click Calculate Curve Number, and this will go to curve number. This is the source layer, and this is the curve number field, and this is a single layer polygon field. I'll explain the rest of this later. And we click OK, and that is how you calculate a curve number. Now I'm going to export that data, and just to show you that how this works. Okay, so first of all, before you export your data, you may want to come in here and turn on your infiltration process switch, and then click Save, and then you'll go to Export Data and Lesson 1 Export. That's where we've been exporting all our data. And I can unselect this and just select infiltration, and now those files have been updated in my Lesson 1 export folder. And if I load this one into Notepad++, you can see that 2, this switch equal to 2 means that we're using curve number. This is our global data, which will be replaced by this local data. And this is the data that was assigned to the grid using the calculator. All right, so that's curve number. I'm going to close that now and do another source of data. So sometimes these, if you look at this polygon, you'll see that it's quite, what I'm doing is I'm selecting these polygons, and you'll see that it's quite fractured. And that can cause some issues with the calculator. So if you're having problems or getting error messages when you sample this data, you can rasterize it. And let's see if we can go to the processing toolbar and look at rasterize, and we want to rasterize a vector conversion. So we want to rasterize vector to raster. And I think we can just use this one. Double click it, and that one was the layer that I had selected, so it's already input into the input layer. And then we can set the fixed field to curve number, and wait a minute, is that the right? That will become the value to assign to the raster. This was optional, so we leave that out. This is georeference units, and we want 30 by 30 because that's our grid cell size, and that's the size of the source data. The source rasters are also 30 by 30. The output extent, we need to set this to the grid layer. So sorry, I didn't mean to click that. I meant to click this, calculate from layer, and then just go find the grid layer and set that as our extent. That's important. Assign a specified no data value. Well, good no data value is -9999. And let's go ahead and save this to file. And I'll just replace this one because that was already done this, so we can just replace that. And then click Run. And if you don't have any error messages, this shows up with no red text or no warnings or anything like that, then you can see your curve number raster. And you can maybe compare it to your curve number shapefile. And so back on our calculator, if your curve number from a single polygon layer doesn't work, you can change to curve number from a raster. And this is just the same elevation and end value calculator. All the calculators that do averaging of data are done with this same calculator. And we, again, remember, we don't need these two. And we can click OK, and that is probing the raster, rewarping it to match our grid exactly, and then sampling each of those individual pixels from the center of the grid. And that is how you do curve number data from a raster. So you have two calculators. There's actually three, but I don't use the Pima County method because they have their own calculators, so we don't bother with that method. And that's it for this video.